It's math time with Heinz. It's math time with Heinz. It's math time.
Hi everybody, in this lesson we're going to continue working with average rate of change. So we're going to continue working with this idea of slope average rate of change. So let's get right into it. So given the three functions here, g, f, and h, order them from greatest to least based on the average rate of change from 0 to 3. So I need to do three different average rates of change here. And again, I'm always using the point x equals 0, x equals 3. And each time I need to find the corresponding y value for each of these functions. So let's start with this first one here. I need the y values, right? Because to find average rate of change, I need change in y over change in x. I need to find the slope between those 2 points. So I have this equation here. So now I told you that the equations are kind of rough to work with, so we're going to turn it into a table. We're going to turn it into a table, x squared, what was it? X squared minus 2x. I'd rather work with a table here. It's just a little bit friendlier to work with. So let me just drag this over real quick. There we go. So for this first one here, let me shrink it down a ton. There we go. A little bit more even. There we go. So I made a table with my calculator. So 0, 0, and 3, 3 is what I get from my table. So when I find my slope is change in y. Subtract my y values, y minus y, over x minus x. So I get negative 3 over negative 3, which gives me a slope of 1. So when we work with equations and I ask you for average rate of change, you have to plug in the points, but I recommend just using your calculator. For the one that's actually a table, it's not too bad. 0, 1, 3, 7. Subtract my y's over subtract my x's. So I get negative 6 over negative 3, which leaves me with an average rate of change of 2. Y minus y over x minus x. And then finally, when I'm working with a graph, I have to start at 0, 0, 2, and then 3, let's go with 9 there. I don't know where that came from. 3, 9 is where that graph goes to. So subtract my y's over subtract the x's in the same order. So I get negative 7 over negative 3, which actually comes out to just be 7/3, which is a little bit bigger than 2, right? Because 6/3 is 2, so 7/3 is bigger than 2 because it's another third bigger. It's 2.33333333. So order these functions g, f, h from greatest to least. So who's got the biggest rate of change? The graph, which is h. So our answer is h, then f, then the table, then the equation. So that's from greatest to least. I'm decreasing there. Greatest rate of change to least. So when we work with average rate of change, we're finding the slope between 2 points. So a family is traveling from their home to a vacation resort hotel. The table below shows the distance they traveled. Determine the slope, the average rate of change, between hours 2 and 7. So I'm using those values there. So again, when I find average rate of change, I kind of set up a fraction with 2 minus signs and figure out what goes in these pieces here. So from 2, 140 to 7, 480. So change in y, 140 minus 480 over change in x in the same order. And again, you can just type this right into a calculator. There's no need to do those computations by hand. You're going to go to math, fraction, and now I just need to type in the fraction. 140 minus 480 over 2 minus 7. And the average rate of change comes out to be 68. Now here, notice it says include units. I need to include units here. So what are my y units? Well, my y units up top are miles. And my x units, right? My x units, it's y over x is hours. Miles per hour. So 68 mph is another way to write that. So again, average rate of change, it's a rate. You're describing how things change. I'm going 68 miles per hour on average. It's not perfectly 68, but overall between 2 and 7, that's the average rate of change is 68 miles per hour. So when we do units, the units are y over x because it's change in y over change in x. So units aren't too hard. You just have to remember to include them if asked for. These next two questions require us to kind of interpret a graph. So the Jameson family kept a log of the distance they traveled. So the x is the time. So 1 hour, 2 hours, 4, 6, 8, 10. I now need to do the distance. What was their average speed? Well, speed is a rate of change. Speed is a rate of change. It's miles per hour. So whenever I see speed, I'm thinking of rate of change. How am I going to find the rate of change here? So we're measuring steepness. I want the rate of change is a measure of slope. It's a measure of steepness. So I want the steepest line segment that I can find. Is it this line segment? Or is it this next line segment? Well, the pink one's definitely steeper. It's more inclined than that second line segment is. So I don't even need to figure out that second one. Or I can do with 6 to 8. This looks pretty steep. I can't judge that off the top of my head, those two there. And then finally, what about 8 to 10? There's no way that's the steepest there. So I can get rid of 4 and 2. I can get rid of 4 and 2 because those aren't as steep. So let's do the average rate of change for this first one. Y minus y over x minus x. Y minus y over x minus x. So I get 70 over 1. So the first hour is 70 miles per hour. And then the second one there, 6 to 8, will change in y. Y minus y. Subtract my y's over subtract my x's. So 120 over 2 is 60. So they look really close, but this first line segment there is the steepest. That's the greatest speed. That's the greatest rate of change. So speed is just a measure of rate of change, and then we're measuring how steep the line segment is. Sometimes you can visually guess it. Other times you have to actually gauge it with computations. Firing a piece of pottery in a kiln takes place at different temperatures for different amounts of time. I really don't care. During which temperature interval did I show the greatest rate of change? So pause the video and see if you can try this one on your own. When was I the steepest? Was it the first hour? Was it the next half hour? That's pretty close to me. 2 to 5, no way that's the answer. That's not the steepest. And then 5 to 8, no way. That's very, very gradual. That's a very small rate of change. I want steep here. So what point is this? This is 0, 200. You got to be careful with your scale there. That brought me to 400, so the middle of that's 200. So change in y, 700 minus 200 over 1 minus 0. So that's 500 if you compute it. And I'll save you the time of typing it into your calculator. And this next one, 900 minus 700, change in y over my change in x is 200 over 0.5. And again, I'll save you the time, comes out to 400. So it should be choice 1. That magenta E segment is steeper than the purple segment. It's hard to judge with my eye, but I can do the computation. I will do 2 more and then we'll call it a day. How's that sound? An astronaut drops a rock off the edge of the moon. I don't care. Here's the function. What is the average speed? Well, average speed isn't going to trick me because that's really a rate of change. They were asking me to find the slope here, rate of change. I started saying slope and writing slope. So I want to find the average rate of change from 5 comma something to 10 comma something. So let me get those y values. 0.8, 0.8 t squared. I forgot to clear it. 0.8 x squared. So when I square, I can't use the variable t, I use the variable x. And I'm going to go to my table and find 5 and also find 10. 520, 1080. Done. I got my points. 520, 1080. I got my points right from using my calculator. So I'm not going to make any algebraic mistakes. I'm going to go to y equals and type it in. So 20 minus 80, change in y over change in x. So negative 60 over negative 5 is positive 12. Positive 12 what? What speed is that? Meters per second. 12 meters per second. That's my average rate of change. Average speed is the same thing as average rate of change. Number 5 just takes it too long for the video, so let's end with number 6 here. The graph below shows the variation in the average temperature of the Earth's surface from 1950 to 2000. During which years did the temperature variation change the most per unit time? Explain how you determine your answer. So when did I vary the most? When did I change the most? I'm looking for the steepest. I want the most change. I want to be steep. So actually, looking at this graph, that's actually the steepest part. I know it's negative. There's a negative slope here. There's a negative rate of change, but it's actually the steepest. So it's from 1960 to 1965 because the line is steepest between this time. That's when I had the greatest rate of change. I know it's a negative rate of change there. I know it's a negative rate of change, but that's when it is the steepest. So again, this wraps up kind of our little mini lesson segment of average rate of change. Change in Y over the change in X. Go get them, folks.